Section 9.1 of Chapter 9 discusses a t-test that compares a sample mean value to a hypothesized mean value and produces a t-value that can let us decide whether we will accept or reject the hypothesized mean value. Section 9.2 deals with a comparison between two groups. These might be an experimental and control group. In the case of the data we're looking at right now, it's a random sample of women's hospital charges and a random sample of men's hospital charges. In any case, Section 9.2 deals with a t-test to compare two groups. In this t-test, the implicit null hypothesis is that cost, for example, is independent of the two-level categorical variable women and men. The alternative is that cost is not independent of that two-level categorical variable. In order to decide whether we will accept or reject our null hypothesis, the t-test that we will use is the one shown on page 284, 9.4. In this example, we have a total of 34 men and 34 women. This goes down to 35, but we start in row 2. So we have two equal-sized groups. In order to perform the t-test, we need x bar W, or the mean for women, x bar M, the mean for men, the variance, VAR W for women, and the variance for men, and we need N. Let's begin with x bar W. It's equal to average for women, Control Shift down arrow, and average for men, Control Shift down arrow, and the variance is equal to VAR for women, Control Shift down arrow, and again equal VAR for the men, Control Shift down arrow. Now, in the formula on page 284, it says that we're going to take the square root of the sum of these two variances divided by n. What that means in this specific formula is that n is the size of either group. It could be the n for women, it could be the n for men, but it is the size of either group, not the combined size. So in this case, n is 34, and it doesn't matter whether we're assuming it's the group of men or the group of women. Now, in order to calculate our t-value, we first say that we will subtract one mean from the other mean. It doesn't matter which way we subtract. We can subtract the mean for women, which is larger, from the mean for men, or the other way around. To simplify the presentation, I'm going to subtract the mean for men from the mean for women, which is exactly what I've done here, and now I have to put a parentheses in front of this, and divide that by SQRT of the variance for women plus the variance for men divided by 34. And I'll have to put another parentheses around this term and the result I get is 0.14. What does this value of 0.14 mean? Well, earlier we've talked about t-values of 2 or greater as being required to reject the null hypothesis, but let's see what the actual probability of a t-value as large as 0.141 is, and in order to get that, we'll simply call it the probability. It's equal to t dist. X is the 0.141. Degrees of freedom in this case are the number of observations in the group of women, -1, plus the number of observations in the group of men, -1. So there are 34 observations for each group. That would be 33 degrees of freedom for each group, so that the total degrees of freedom are 66. And this is a two-tailed test because we didn't specify in advance whether men were more costly than women or women were more costly than men. And when we hit enter, we see that the probability of getting a t-value as large as 0.14 is 0.888. On the basis of that probability, we would not reject the implicit null hypothesis that cost is independent of the two-level variable women or men. Stated another way, we would not reject the implicit null hypothesis that men and women are no different in their costs.